All right, here we go. So we said today we're going to be doing what?
Inequality.
Solving absolute value inequalities. Solving absolute value inequalities. Now, as you can imagine, it's very similar to solving absolute value equations. But before we jump right into that, let's do a little thought bubble. Let's say I gave you this. Absolute value of some number is less than 5. Just chew on that for a second. Take 8 seconds in your head mentally to come up with as many values of x that you can. That will satisfy that. Don't say anything, just think about it. Think of what value of x you could substitute in for that inequality, and it would be satisfied on the left and the right. And I'll give you a hint, there's more than one. Let's hear from Ali. You come up with a number that will satisfy that inequality?
Yeah.
Pick one. What's up? 4? You guys agree with that? 4?
Yeah.
Alright, I'll tell you what I'm going to do. I also agree with 4.
I don't know why this is going so slow. What is going on?
So I'm going to put 0 here. Here's 4. Can you give me another one, Ali?
Negative 4.
-4? Ooh, you guys agree with that?
Yeah.
So absolute value -4 is 4 is 4 less than 5. Sure. Give me another one, Ali. -3. Okay. Curveball, Ali. Give me one that will not work. -5. What do you guys think about -5?
It's not equal.
Absolute value of -5 is 5. Is 5 less than 5? No. Give me another one that won't work. -7. You guys buy that? Now, let me ask you this. If you had to just generalize it, instead of just listing off all the numbers that will work and won't work, how could you summarize that into what will work and what won't? You guys buy that?
It wouldn't be everything between -5 and 5.
Which one?
Anything bigger, like way smaller than -5 and -5. No, smaller than 5 and
Right here, right now. All right. Most of you guys are kind of stumbling and mumbling your way to the right answer, right? So basically, it's everybody from -5 to 5, but not including -5 to 5, right? So you could say, I think I heard Jenna saying it, everything that's greater than -5, but at the same time less than 5. Now on the graph, on a number line, you just show that. Hopefully you guys remember this from Algebra 1. Open circle.
Yes.
Open circle means everybody leading up to it, but not including it. Right? If I actually wanted to include 5, then I would shade in the circle. All right. Same idea, but now let's go the other way. If I said the absolute value is greater than or equal to 5. And so you already got the gist of it, so I'll only give you 7 seconds this time. Think of as many values as you can that will satisfy that inequality. Oh, by the way, nice job, Ollie.
Oh, that's your job.
Group C is racking up the points today. All right. Let's hear from Rachel. What do you think, Rachel? What? Give me one of the values that'll work for satisfying that inequality. 6? You guys agree with that? She sounds very confident. 6? Does that work? Sure. Let me get a little number line going here. Oh. Huh?
It was one of those.
There we go. So we said, here's 0. He said 6 is going to work. Give me another one, Rachel. Negative 6, you guys buy that?
Yeah.
Sure, absolute value negative 6 is 6. 6 is greater than or equal to 5. Yeah, that works. Give me one that's not going to work, Rachel. 5 this time? Notice I put a little line underneath it this time to make it a little more complicated. 5 is going to be here. 5 is actually looking like absolute value of 5 is 5. Is 5 greater than or equal to 5?
Yeah.
Sure, so give me one that's not going to work. You were just playing that time, right?
4.
4, how about 4? Do you buy that? So 4 is not going to work. One more that's not going to work, Rachel. 3, sure. So in general, can we make a rule about when it's going to work and when it's not going to work this time? How can we generalize that? Anybody, help me out. Less than or equal to... Well, we got equal to sign this time. So it can't be equal to 5. So the ones that... Well, I want to know which ones will work. Which ones will work? Greater than or equal to 5. So that's everybody from 5. Notice I'm closing it in this time. And out this way. Anybody else?
Less than or equal to negative 5.
Less than or equal to negative 5. All those guys will also work, right? You put anybody in here that's more negative than negative 5, you take the absolute value of it, it's going to end up being positive, but it's going to be more positive than a regular 5. Look, if you can understand this, the rest of today, it's patty cake. That's all it is. Look, if you learn nothing else from me today, if you learn nothing else from me today, here's the idea. If you have absolute value, blah, 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 is less than a number, your answer will always look like this. It's always going to point inside. If you have absolute value is greater than or equal to some positive number, then it always turns out. Less than, in, outside, out. Once you master that, it's the exact same thing as yesterday. So, let's do an example. Ejemplo. Our job is going to be to solve for, let me just say, solve the inequality. And this time I'm going to introduce something a little new. I'm going to say, write your answer in interval notation.
It's just a big word, Nancy. Don't get scared.
Yeah, it's nothing. Interval notation. Interval. And let's do absolute value of 2x minus 7. All right. You guys remember the steps we talked about? You solve an absolute value equations or inequalities. What was the first step? Starts with an I. Isolate, right? Do we need to do anything to isolate this one? Nah, he's already by himself. So isolation, check. Next step? Separate. and it's separated into two separate inequalities. Now, here's the deal. You need to remember what we just talked about as far as the setup goes. When it's less than a positive number, you already know what it's going to look like, right? You know right away your final answer is going to be stuck inside two different numbers. Now, the only question is, what are those two numbers? But here's the deal. When you're solving it, you can set up what's called a compound inequality. Because you know that your final answer should say x is going to be stuck in between blah-de-blah-de-blah and blah-de-blah-de-blah. Right? So when you separate it, this is the only one where instead of making two completely separate equations, you can set up a compound inequality. And here's the blah-blah-blah, just like we said at the beginning, has got to be less than 5, I guess in this case less than or equal to, and at the same time greater than or equal to negative 5. Same idea. So we can say that in one sentence. Here's the blah-de-blah-de-blah, and we're going to trap it in between 5 and negative 5. That's the only piece that makes this a little different from yesterday. Instead of writing two separate inequalities, we can combine them together because you're really only talking about one region here. Before we were talking about two separate points. So I needed two separate equations. Here I got one big region, so I got one big inequality, what's called a compound inequality. So it looks a little gross, but it's really the same as having two separate ones. You follow the same steps. We still need to get x by itself. And by the way, if you get here, the rest is easy. The hardest part is knowing how to separate it. So, how do I get x by itself here? What would I do if I just saw this piece? Add 7 to both sides. Same thing, except I got 3 sides. So I'm just going to add 7 to everybody. Just going to add 7 over here, and over there. Alright, and we simplify. Negative 5 plus 7 is 2. Less than or equal to 2x. The 7's canceled out. And I got 12. Alright, pretend this isn't here. How would I get rid of the 2? Divide. So we divide everybody by 2. And you end up with 1 is less than or equal to x, which is less than or equal to 6. And we're almost done. Alright? So, there's our solution. So now we know that we can put 1 and 6 on the number line. And it's everybody in between. Over here, I know that that's 1 and 6. And if I wanted to make it set notation, all I would have to do is put a little x such that with a little squiggly bracket in front. And there's your set notation. Alright, that's just silly math stuff. Just get used to seeing it because you're going to see it in pre-calculus and calculus. Now the last thing we got to do is we got to put it also in interval notation. Interval notation, believe it or not, is actually meant to make your life easier. Instead of writing all of this stuff, x, bracket x, such that 1 is less than or equal to x, less than or equal to 6, close bracket. What they did is interval notation describes intervals, right? You know what an interval is? It's kind of like the length in between something. So if I say, anybody run track? Like if you're running a mile, you might measure the time of a lap as one interval. It's like the time that it took you to just complete that one lap from beginning to end. And then you might have a second interval for the second lap, and then third, right? Intervals always have a beginning and they have an end. So interval notation does just that. It's asking you, what's the beginning of this interval? Well, what does it look like the beginning is? Where does it start? Where does my region that's going to satisfy this inequality start? It starts at 1, and where does it end? At 6. So we just say 1, comma 6. Now, here's the only other thing that you got to be careful about. It's a closed circle, so we're actually including 1 this time. So in order to show that, I'm going to use what's called a closed bracket. You see it's got those square edges? That's the way of showing that it includes 1. It's not strictly greater than, it's actually greater than or equal to. And then same thing on the other side. That is integral notation. So interval notation just tells you where to start, comma, where you end, and then you just got to watch the brackets. So here's the idea behind the brackets. If you're including the endpoints, then you use the square brackets. If you're not including them, like if they're strictly less than, then you would use parentheses. And I usually like to put all my vocabulary stuff in blue. It would be difficult.
You need a little closed circle, right?
Yeah. Sometimes you can scoot around. All right. And let me put a magic box.
There's green, or there's a shade of blue.
I'm saying, man, this is just not wanting to cooperate. I will never give up. I will not be defeated by this small word. Bang. That's my, see, that's why people always try to write green. So I always keep one that's just white. So that way you can do my little eraser right. Alright, no one likes green anyway. Alright, here we go. So there's our final answer. On a number line, it would look like that. In set notation, there it is. And in interval notation, sweet and simple. Que fácil. Right? So, you guys try example 2. Ejemplo 2. Let's do 3 times the absolute value of 2x minus 7. And we're going to subtract 2 from that. And we're going to make it greater than 13.
Too many numbers. What?
Okay.
It just looked weird, yeah. I thought it was like a random bracket or something. It's 13.
All right, now I'll give you a hint. First step starts with an I, rhymes with trisolate. Isolate, sure, so be careful about how you want to do that. I'll give you a second hint. Think about what the final ants actually know. Let me set this up first, because I don't want to. That's your big stuff. All right, so isolate, right? What I'll do one. I just don't want you to have to get all frustrated. You know it's gonna be messy and get mad at me. If I'm gonna isolate this thing, what do you gotta do first? What?
No, add the 2.
Add 2 divided by 3. What do you want to do first?
Add the 2.
Add the 2 first. you serious?
Oh, maybe.
Why does it keep on doing
It's Monday.
it? Man. So then you end up with 3 times 2x minus 7 greater than or equal to.
You put it equals instead of.
I'm sorry, it's greater than, not greater than. Now what? 9 divided by 3. Notice we're not going to distribute. This time it wouldn't make a difference, but sometimes it does, so be careful. It's better off just isolating before you do anything else. So here we have 2x minus 7.
Isn't it the same thing?
Is it?
Yeah.
Well, except it's less, greater than equal to.
So here's the deal. We already know what this answer should look like. Let me break out my mystery box. I should have done this last time. Oh my gosh. Okay. Let's do.
I can see through it.
It's not a mystery.
Yeah, let's do a pattern fill. There we go. Mystery box. We know what's behind mystery box. It's got to either be greater than 5 or less than who? Negative 5. Can I be greater than 5 and less than negative 5 at the same time?
Why not?
I'll give $5,000 to anybody who can tell me a number that is greater than 5 and is also less than negative 5.
Oh, wait.
Oh.
Could it be 0? No?
0 is neither.
No.
0 is stuck in between, right? You can't be in 2 places at once. So, can I set up one inequality this time? Like I did over here. You see the difference? Like here, I can be a number that's greater than negative 5 and less than 5. I can do that. I can be one number that satisfies both. But down here, I can't be greater than 5 and less than negative 5 at the same time. So this time, I need 2 separate inequalities. Remember, we know what the answer is going to look like. We know it's going to be somebody over here and somebody over there. Like using some common sense, because it is pretty similar to example 1. You should know that's going to be a 1 and that's going to be a 6. But let's pretend you didn't. So I know blah, 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 blah is either going to be greater than 5 or whatever is behind here has to be less than, who do we say? Negative 5. So I have 2 separate inequalities. Now if you want, it'll make it a little neater if you're writing over here. Blah, blah, blah could be less than negative 5, or blah, blah, blah could be greater than 5. Now, who's the blah, blah, blah? 2x minus 7. So there are your 2 separate inequalities. 2x minus 7 is less than negative 5, or 2x minus 7 is greater than 5. Now, you guys go to work. Let me just finish line. You guys come up with x over here is greater than 6. So this one is x is greater than 6. This ends up being x is less than 1, right? So on the number line, you know that that's your 1, that's your 6. Again, greater than's turned out. Hip hip hooray. And let's talk about interval notation. Well, first off, set notation is just this, but in funky brackets. So set notation says little bracket x such that x is less than 1, and then you actually have to write or
All in one?
x is greater than 6. Yep.
Oh.
It is other. X such that x is less than 1 or x is greater than 6. Then interval notation. Notice this time we had 2 separate intervals. Okay, so this is where it gets a little funky. Remember I said interval notation always has a start and an end. So let's just look at the first one right now. where does this one start? Keep in mind, when I say start, you always start on the left and then read to your right. Where does this one actually start? We're on the right track. Except infinity is over here. Negative infinity. So this interval, as weird as it may be, the starting point is negative infinity. Absolutely.
It's parentheses, right?
And you got to use the open bracket, or the parentheses, you're right, not closed. It's got to be open, nice, smooth, because you can never actually equal infinity. Right? Infinity is a concept. It's not a number. So anytime you have infinity, whether or not this circle is open or closed, it does not matter. Infinity, the infinity side is always, always, always open. Now, when I get over here to 1, which is where that first interval stops, if that were a closed circle, then I could have a closed bracket. You see what I mean? Like half of it would be open and half of it would be closed. Because you're not including, like this time it's just open because the circle is open. But if I close that circle up and said, hey, it was actually up until 1 and including 1, then I would have to go and have the closed bracket. Okay? Now, that's just one of the intervals. You also have this guy over here. Are you serious?
So it starts at 6 and ends at infinity?
This one starts at 6. What is going on? This one starts at 6, ends at infinity.
So when you put or and in between?
Aha. Mathematicians are lazy. They're notoriously lazy. So they come up with symbols when symbols don't need to be created. They'll just create it just to make their lives a little easier. Instead of writing or here, they write this little symbol. This little U. It's really silly. That U is technically a union. So it's like the interval from -1, or from negative infinity to 1, union 6 to infinity. But basically, it just means the same thing as or. Okay? There's another one that we don't use a lot in this class, but you might see it in pre-calc, is if you see an upside down here, like an N almost. That's not or, that's and.
Yeah, they logical.
Mm-hmm. Yeah. So the union is or, the intersection is and. But we don't really use the and a whole lot. That's it. Qué fácil, no? So there's our answer and interval notation. Now it's your turn. Let's do a little U try, shall we? You guys got this? It's going to disappear. Ready? Ejemplo 3. A ustedes les tocan. Let's do... Oh, I couldn't get out of here without doing some fractions. Oh. 1/2 times 3, the after 3 halves minus 4.
Oh, I'm going to multiply it by 2. I'm going to get rid of it.
And that is greater than or equal to 1/4. Oh my god.
Now I can multiply it by 2, sure.
I'll give you guys 4 minutes in your group. See what you can work out.
I'm multiplying by 4.
You got to be careful.
Wait, what did I get? If you multiply everything by 4, would you have to multiply the...
Don't ask me which one.
I'll do it by myself. I don't know. I don't want to help you anyway.
Yeah. So you.
Alright, so fractions, yeah, I get it, they're scary. Here's where you gotta be careful, guys. One, if you want to go through and try to clear everybody out, do you see how you can't do it yet?
Yeah. Here.
Look at it this way. If I had, like, so the idea is some of you guys may have tried to go through and multiply everybody by 4. Anybody do that?
I tried, but
Yeah?
it wasn't.
The problem is you can't multiply here and there. Because then you're not being true to the equality of it all. Right? So let's just pretend that's equals for right now. Let's say that A times B equals C. Right? So this is like A, this whole thing is like B, and that's like C. If, like normally you can say, okay, whatever you do to the left side, do the right side. So if I want to multiply the left side by 4, I can multiply it by 4. But what I'm not going to do is do 4A times 4B equals 4C. Because then I didn't multiply the left side by 4. I multiply the left side by 16. You see what I'm saying?
Yeah.
So if you want to try to clear these fractions out, sure. But you're going to have to do it one step at a time. First thing you're going to have to do is get rid of the 2. So in that you would just do, I mean, there's really no fraction thing there. You just multiply both sides by 2. And you end up with I multiply both sides by 2. 1/2 times 2 cancels out, right? Notice I'm not going to multiply it inside here because I just did the left side. When it's multiplication, you don't distribute. I'm not distributing into that and there because these are getting multiplied together. They're not adding. Distribution is when it's distribution over addition or subtraction. So no distribution there. Instead, I just have the absolute value of 3 over 2x minus 4. Now, what's 1/4 times 2? That should end up being 1/2. So you guys are getting better at fractions. Remember, 2 is like 2 over 1. 2 over 1 is reduced down to 1/2, right?
So this would be 3x.
Now, once you're here, you can go ahead and separate, right? We just isolated it, so separate it. Now the question is this going to turn in or is it going to turn out? That's why we have notes. Greater than always turn out. Now look, if you need a way to help you remember this, it's kind of corny, but if it works, it works. Look, if you are greater than somebody, right? Greater than. If you're greater than, it's like you are stronger, right? Greater, stronger. So think about I'm stronger than you, so I'm flexing. Get it? I'm flexing. I'm like, yo, what? Get at me. So it's outside. Now, if it were less than, see greater than, you see it's going out. Right? Now, if it were less than, that means you're weaker than somebody, so that means you need to get in the gym. Right? So less than always turn in, and it kind of looks like some barbell.
That makes sense.
Right? So less than turns in, greater than turns out.
I like the way you're doing this.
Okay? So this is greater than, I'm already strong, I don't need to lift weights, so I'm turning out. Right? So that means I need 2 separate inequalities. Here's the first one. Just repeat what we already had, except I can lose the absolute value. Here's there. Or mystery box is less than
You flip this.
or equal to who?
-1.
Negative 1/2. That's the hardest part. If you can get that, and if you can deal with fractions, and the rest is patty cake. Right? What's up?
You want to get rid of the fractions, this would be what how to do it, right?
Now you can go ahead and clear the fractions out like this.
Multiply by 2.
I would go through and multiply everybody by 2. So then my new equations would look like 3x minus 8 is less than or equal to -1. And you can do this one too while you're at it. 3x minus 8 is greater than 8. That's what I like about math. You know, it's really the same thing, only different. You just take what you already knew, and then you just twist it a little bit. And then you take what you knew and you just twist it a little more. And eventually you go from addition all the way to calculus. It's all the same things, just building on top of each other. Now, once you get here, I trust you guys can finish it off from there, right?
Very good.
You could probably get rid of that fraction.
It's going to be another fraction.
Yeah, man. Don't be scared. Well, this one, it kind of got turned around, didn't it? The -1. And I think it helps. I don't know why. I don't know why it does that. That's why I think it helps if you go ahead and draw the picture first. Because then it helps you remember, oh yeah, I need to be less than or equal to a certain number. And then this one's going to be greater than or equal to a different number. So that's why this sign, yeah, it kind of got flipped around. So here's less than or equal to the negative version. So you solve it, right? What's the left side end up getting you?
It would be 3 divided by 7.
3 divided by 7? 7 divided by 3. Right? Add 8 to -1, you get positive 7 divided by 3. So I got x is less than or equal to 7/3. Which, if I were on a number line, yeah, where is that on a number line?
And then between 3 and 2. More towards
7/3, yeah, that sounds about right. Because 6/3 would be 2. 9/3 would be 3. So I know I'm somewhere in between 2 and 3. Closed circle. And going to the left. Over here, what does x end up being? Greater than or equal to... What's up, Miss Mary?
Why did you put 7 over 3 in between 2 and 3?
7/3, like if you did it as a decimal, it would be 2.3 repeating.
Oh.
Alright, so over here on the right, good question though. Over here on the right, x is greater than or equal to, we should end up with 9, right? I'm sorry, 3. Add the 8, you get 9, divided by 3, you get 3. So then, the other one is right. Oof. So let's do something like that.
They're really close.
Yes, indeed. This one ends up being almost all the real numbers. So there's your number line. How do I say that? In interval notation. Where am I starting for this left interval?
Negative infinity.
Negative infinity. Whoops.
Could be a bracket, right?
Infinity. Always open. Can't include infinity. But over here on the 7/3, now it's closed. Because I got a closed circle. Then I got a little U, and then from Where does this next one start?
3.
3 off to
Infinity.
infinity, open or closed? Open. Infinity is open. There you go. Que fácil. Alright. Now, let me throw one extra curveball in there. Just because you might see something like it on your notes or on the test. Just saying.
So were you making?
Mm-hmm.
How was you making?
Example 4. Little trap. It's super short though. It's super short. Let's say I gave you absolute value of 3x minus 12 is greater than or equal to negative 3. Tengan cuidado. No solution, right? Write it down so you don't forget. That's like the class. Don't know about it.
Yeah,
No solution. Absolute value can't equal a negative.
that's not. You're trying to trick us.
I don't believe you.
But it's not equal to, is it? What does it say?
Oh,
Greater than or equal to negative.
I think yes.
So now what?
So you have to solve it, really?
What's up?
So you have to solve it, right?
Use a little common sense, guys. Think about a number for x.
3.
Sure, plug a 3 in. 3 times 3 is 9 minus 12. Negative 3, absolute value of 3 is 3. Is 3 greater than or equal to negative 3? Sure, so did 3 work? Yeah, pick a different number.
Negative 3.
Plug in negative 5. 3 times negative 5 is negative 15, negative 12. Okay, so negative 27, absolute value, positive, greater than or equal to negative 3? Sure, I'll give $5,000 to anyone who gives me a number that doesn't work.
0.
0, negative 12, 12 greater than or equal.
Wait, all real numbers.
No matter what you put in, this is going to end up being positive. That stays negative. So in this case, it's not no solution, it's all solutions. Because no matter what you put in here, this is always going to end up being positive. This side is always negative, and positives are always bigger than negatives. So you could say all real numbers.
So is that always when it's negative?
Not necessarily, because if I made this less than or equal to, now it's a solution
But
again.
if it's greater than...
Yeah, sure. And by the way, you could say that in interval notation, like so. All right. Make sure you grab the homework on your way out. Remember, guys, if you want to check your work, the answers will be on the website. It won't show you how to do it, but it'll at least tell you what the answers are so you can check.
You hurt my brain with that.
I drop knowledge like bombs. That's what I do.